Okay, let's dive into this. We're going to tackle a question that seems super simple on the surface, but it's actually the battleground for two totally different philosophies in science and statistics. The big question is, are you a frequentist or are you a Bayesian? I mean, we all think we know what probability means, right? It's something we hear about all the time. The chance of rain tomorrow, your odds of winning the lottery, the likelihood a coin lands on heads. But have you ever stopped to think about what it actually is? Well, it turns out the answer is not simple at all. In fact, this one question basically splits the entire world of statistics into two huge camps, each with a fundamentally different way of seeing reality. You've got the frequentists and you've got the Bayesians. So to really get a handle on what makes them so different, let's just take a quick look at where these two massive ideas even came from. All right, so let's meet our two main players. On one side, you have the frequentist school of thought. This is the classical stuff, the statistics that most of us probably learned back in high school or college. And on the other side, you've got the Bayesian approach. It's actually an older idea, but it's having this massive comeback right now. And it's the engine behind a ton of modern AI and machine learning. And the history here is actually kind of wild. Bayesian ideas have been around since way back in 1763, but for almost 200 years, they were mostly just ignored. Then, boom, in the 1930s, frequentist methods got established and they just completely took over the world of stats. It wasn't until the 1950s, really with the invention of powerful computers, that the Bayesian way of thinking started to make its big comeback. So what is the deep disagreement, this huge philosophical rift between them? Well, it all boils down to how they answer one simple but incredibly profound question. What does the word random actually mean? So for a frequentist, randomness is real. It's an objective property that exists out there in the world, just like an object's mass or temperature. A coin flip is random because the universe itself has some inherent unpredictability, and the only way we can get a grip on it is by running an experiment over and over and over again. But then the Bayesians come along and just flip that whole idea on its head. They say randomness isn't a property of the world, it's a property of our knowledge. The word random is really just a label we use when we're ignorant about what's truly going on. Let's use the coin flip, because it makes this crystal clear. A frequentist would say the 50% probability of heads is a real physical fact about that coin that you could prove by flipping it 1 billion times. But a Bayesian says, hold on, the flip isn't random at all, it's just physics. If you knew the exact force of the flip, the spin, the air currents, you could predict the outcome with 100% certainty. That 50% number doesn't describe the coin, it describes your lack of information. And the philosopher Frank Ramsey just absolutely nailed the Bayesian idea back in 1926. He said probability isn't about how often stuff happens, it's about our degree of belief. Basically, how confident are you? And more importantly, how willing are you to place a bet based on that confidence? Okay, so that's the philosophy. But how does this play out in the real world? Let's look at how this core difference completely changes how they actually work with data to figure things out. It makes sense, right? Different worldviews mean different toolkits. The frequentists use methods like maximum likelihood estimation. Their goal is to find the one single best answer that makes the data they've seen most likely. The Bayesians, though, they use Bayes' theorem itself. It's like an engine designed specifically to update your beliefs as you encounter new evidence. It's literally a machine for learning. Here's a great little example to help you think about this subjective ignorance idea. Imagine you need to figure out the exact cost of a pile of sand. Now that cost is a single fixed number, but you bring in 3 appraisers. The first one knows the quarry prices, but that's it. The second is a wizard with shipping costs, but knows nothing else. And the third is a tax law expert. See? The cost itself isn't random, but for each of them, there's uncertainty because they're all missing pieces of the puzzle. So, given that they start from different places and use different tools, it probably won't surprise you to learn that they end up with very different kinds of answers. And this right here is maybe the biggest practical difference between them. A frequentist will give you a point estimate, a single number, like an average, or maybe a confidence interval around that number. But a Bayesian gives you something way richer. They give you a posterior distribution. It's not one answer, it's a whole landscape of possible answers, showing you exactly how much you should believe in each one. This is the real magic of the Bayesian method. It's this beautiful, formal process for learning. You start with a prior belief, basically your best initial guess. Then you collect some new data. You plug it into Bayes' theorem, and out pops a posterior belief. your new, updated, more informed guess. And here's the kicker. That posterior now becomes your new prior for the next piece of data that comes along. It's a constant, powerful loop of learning and refining.
So, you might be thinking, are these two sides just destined to argue forever? Is it always going to be one or the other? Well, not exactly.
This is where things get really fascinating. It turns out that data is the great equalizer. With enough data, their differences start to just melt away. See, a Bayesian might start with a personal, subjective belief, but as more and more evidence rolls in, that initial guess starts to matter less and less. Eventually, the sheer weight of the data just overwhelms the starting point. So as the number of your observations, what we call n, gets massive and heads towards infinity, something amazing happens. The Bayesian's broad landscape of possibilities starts to narrow. It gets sharper and sharper until it collapses into a single perfect peak. And guess where that peak lands? In the exact same spot identified by the Frequentist method. With enough data, they actually point to the very same answer. All right, let's pull this all together. You can see how that one core disagreement is randomness in the world or in our heads causes this huge domino effect. It changes the tools they use, the answers they give, even how much data they need. The key trade-off is pretty clear. Frequentists need lots of data to aim for that one objective truth. Bayesians can start with just a belief and learn from every new piece of information, big or small. And really, if there's one thing to take away, it's this. The Bayesian framework is so much more than just a statistical tool. It's a formal system for reasoning when you're uncertain. It gives you a mathematical recipe for how to blend what you already think you know with what you're seeing right now, helping you learn and adapt as the world changes. And that leaves us with one last, kind of mind-bending question to chew on. If the Bayesian view is right, if randomness is mostly just a story we tell ourselves to explain our own ignorance, what does that imply? What could we predict if we actually knew everything? In a world with no ignorance, would anything be random at all? It's a thought that really challenges how we think about chance, destiny, and the very limits of what we can know.